Welcome to this new tutorial video where we will be minting an NFT from a mobile device in Flutter using a custom program to mint NFT on the Solana network. Today we will be using the login system and NFT display that we have developed in the previous two videos. And we will be adding the functionality to mint or create a new NFT with an image and metadata file previously uploaded to the IPFS service from QuickNode. We will be minting our NFTs on the Solana network by interacting with our NFT minting program directly on chain, which we developed in the video, creating NFT on chain from scratch in Solana. Link in description. As a previous step, we must have the image files and metadata of our NFT ready in an IPFS service. We will use this service offered by QuickNode. We have the following images that we will use for our NFTs, and we have built the JSON files for each of the images with the following format: name, symbol, and description. Image URL. Here we will paste the URL of each image file in its corresponding JSON, a list of attributes, and a list of properties, where we have included creators and files. And finally, the collections parameter, if your NFTs will be part of any collection. Once the JSONs are ready for each image, we must upload them to IPFS storage, since the CID address of the JSON will be used in our app to mint our NFTs. Let's start with our code. Let's copy the repo address of our previous tutorial, flutterfetch NFT Solana QN. In a folder of our choice, we do git clone with the copied address. We load the created directory and run flutter pub get. Now we open our pubspec file and import the Borscht and Borscht annotation libraries as shown on screen. And we will also import this build runner dependency under dev dependencies. We are going to create our .env file just as we did in the previous tutorial. Our file will have these two variables, QuickNode RPC URL and QuickNode RPC WSS. In both, we will place our QuickNode RPC for the Solana DevNet, and in the second, we will change the HTTPS header to WSS. This RPC allows us to use the QuickNode NFT API service to receive NFTs from a Solana account. One of the main challenges to communicate with the Solana network is the serialization and deserialization of data. In our app, to be able to communicate with our program in Solana, we will start by creating a folder anchor types, where we will create the file NFT parameters, Dart. We will use this code where we import the Borscht annotation library. We define an import of the automatically generated NFTs parameters .gdart file. We place the Borscht serializable tag. And we define the NFT arguments class, where we will specify all the parameters that our Solana program receives, so that they are serialized and deserialized in the interaction process between our app and the program in Rust. Now we will execute the command flutter pub run build runner build. That will generate a new file with the serialization deserialization code for any file with the Borscht serializable tag, and we can see the new generated file. With this step ready, we are going to create in our services folder the mint.nft file. To mint our NFT from the Flutter app, we will need the address of our program on the Solana network, along with all the accounts used in the transaction and the seeds, just as we defined them in the program. We suggest you refer to the tutorial where we created this program if you have any questions. We will start by importing all the dependencies we will use. We are going to place this Solana Web3 library in our pubspec, which will help us to work with buffers for seed creation. we will create our createNFT function. It will return a future of type string to return some message to the UI to display on screen. Our function will receive the Solana client that we have initialized on the home page, the JSON CID of the NFT that we will try to mint. This will be entered by the user for the purposes of the present tutorial. A name and a symbol as parameters that our program receives. For the amount and price, we will place the values of 1 when interacting with the program. We create an instance of Flutter secure storage to read our secret phrase, and with it, we generate the key pair to sign the transactions. So our account with which we have logged into the app will pay the transaction and will remain as the authority of the NFT. We are going to define the address of our program. This we can access in the Rust program code that we created in solpg, and we will obtain the public key of our program through the ed25519hd public key class and the fromBase58 method of the Solana library. We will get the mint address of our NFT through the findProgramAddress method of the aforementioned library, which will receive the program key in Solana, and the seed that will be a list with the data that our seed receives as specified in the program. First, the mint string in bytes that we get from the buffer class, from string method of the Solana buffer library that we just imported. And secondly, the ID we will use also taken to bytes as follows. For the ID, for the moment, we will simply use a random number as follows. We are going to declare the rest of the accounts needed for our transaction. The program associated token account address. This is a standard address on the Solana network to associate accounts with tokens. The system program ID is the base program of the Solana network. The token program ID, the main program, with all the basic functionalities of the tokens on the network. The rent program ID, the Solana rent program. The Metaplex program ID is the standard Metaplex program whose address we can obtain from the link that we leave in the description. And now we will create our associated token accounts, again using the findProgramAddress method and in the seed parameters as indicated in the Solana documentation. We enter the wallet address, the token program ID, and the mint account that we created moments ago. In the program ID parameter, we will place the associated token account program ID that we obtained previously. We would be missing to define the master edition account PDA that we built with the seeds, the metadata string to bytes, the Metaplex program ID to bytes, the mint account of the token to bytes, and the edition string. In the program ID parameter, we will send the Metaplex program ID. Finally, the NFT metadata PDA in a very similar way to the master edition, but only with the seeds metadata string to bytes, Metaplex program ID to bytes, and the mint address to bytes. Now we will create the instruction to mint the NFT. We create an instruction list that will contain a single instruction that we will declare through the forMethod method of the anchor instruction class of the library that we imported as Solana anchor. Our method will carry in the program ID parameter the address of our Solana program. The method will carry the name of our function in the Solana program as we can see in the Rust code. It will carry as arguments an instance of our NFT arguments class that we declared at the beginning of this tutorial, encoded as a byte array through the library that we imported as Solana encoder. Remember that our class takes the arguments ID, which we will transform to bigint, the name and symbol that we receive in our function as parameters, the JSON URI that we will build with the prefix of our IPFS files from QuickNode and the CID that we receive as a parameter. Remember that if you are using another IPFS service here, you must place the complete address of your JSON as returned by your IPF service. And in price and quantity, we will place the integer 1 transformed to BigInt. We call the toBorscht and toList methods available for our NFT arguments class, and we just have to place all the accounts that our program will use in the following order. The signer and authority accounts, both with the isSigner parameter set to true, and both will be our account with which we have logged in. Then the mint address that we obtained previously. The associated token account also obtained previously. The address of the associated token account program, the rent program, the system program, and the token program. The Metaplex program address and our master edition account and NFT metadata accounts that we derived earlier according to the corresponding seeds. The last parameter that the forMethod method will take will be this namespace with the global value. We declare a Solana message with our instruction, and then we send the transaction with the send and confirm transaction method for our Solana client with the message we just created, our main account as signer, and the confirmed commitment to wait for the transaction to be confirmed. Finally, if all goes well, we return the text successful transaction with the transaction hash, which we have saved in the signature variable. Let's go to the home file to update our UI. First, we will place this card widget with the text mint NFT and a collapse expand icon. That when expanded, it will clear the content of this CID controller input controller. It will change this mint NFT expanded bool and place the show NFT expanded to false so that the NFT display tab closes if it is open. We will declare the mint NFT expanded variable and these input controllers to capture the data with which we will do the mint. Now, if the tab is expanded, this container will be displayed, which will carry the following elements in a column: a text field for the name of the NFT, another for the symbol of the NFT, and finally, a row with the input field to place the CID and a button to send the data, saving these variables in the controllers. And by placing this fetch NFT to true, the create NFT function will be triggered, as we will see in a moment. And this new fetch variable we will set to true, and we will already give it utility. We declare as appropriate all the variables we are using. And finally, if a data submission has been made and the Mint NFT tab is expanded, then we display through a future builder some of the following widgets: a progress bar if the state of the future is waiting, any error, or the data sent by the function of our future. The future builder calls the create NFT function that we will create below and will simply consist of calling our create NFT function that we created in the Mint NFT file with the Solana client, the CID address, name and symbols entered by the user. This call is made only if the new fetch variable is true. This variable serves to prevent the function from being called unnecessarily. We observe that our function returns the result of calling the create NFT function, which, in case the minting is successful, will return a corresponding message. Otherwise, it will return some error. If the new fetch variable comes in false, an empty string will be returned. Let's run our Flutter application, and we will create a new account. We enter a password, and on our home page, we can already display the Mint NFT tab. Here, we will enter a name and a symbol, and in the CID, we will copy from our QuickNode IPFS service the CID of one of our JSON files that we have uploaded and paste it where it belongs. We send the transaction and we see that it gives us this result. Since the account does not have funds to pay the transaction, let's reload our account on solfaucet.com, and with enough funds already available, we send the transaction again and get the result of successful transaction with the corresponding hash. If we open the Show NFTs tab and update, after waiting briefly, we see our beautiful NFT that is now part of our account. We can verify the balance, the cost of the operation, and if we go to Solana FM and select the QuickNode DevNet, we see our NFT minted correctly from our app. We hope this video will be very useful to you. Subscribe, comment, and like to support us on this path of growing together in the Web3 world. Until next time.